This is Fix It for the Jets, and we're addressing the egress time at the Metlife Stadium. It's about 45 minutes too long, and we hope our solution can fix that. It involves rerouting traffic throughout the stadium using reversible lanes, dynamic merge control, and altering the toll booths. The importance of this is for the Jets to deliver a better product to the fans, allowing fans to be happier and get out quicker, and hopefully other NFL teams will use our solution to better their stadiums. Our solution is innovative, presents a cost-effective way of fixing the problem. It's easy to use. The cost is probably less than $50,000, and the fans will get too confused using the new traffic patterns. We left a few things out of the project with the simulations because they were too time consuming. So we found in the little simulations that we did that these rerouting had a great impact on the time leaving the stadium.
Hi, I'm Brandon. I researched the monorail, but we determined that this solution would be too expensive and would not be feasible for the Jets.
My name is Bosco. My idea was the smart parking technology. While it has many uses, it won't have an impact on reducing egress time.
Hi, my name is Rachel. My research included creating a mobile app for the fans to be better informed about the post-game egress. In the end, we did not have the capability to execute the solution thoroughly.
This is Kieran. I researched the bottleneck removal techniques. These are what we eventually used to create our solution for the project. We got our research from the Texas A&M Traffic Institute. For the initial idea of the project, we looked at the 4 exits. We looked at the egress time of the northeast exit and saw that it was within the Jets' required time. And then our focus was on the northwest exit, south exit, and the southwest exit. For the southwest exit, we decided to use reversible lanes to move them around here and onto 3. And for the south exit, we did some changes to the toll booth and reopened the lanes going eastbound here to get them onto 95. And for this northwest exit, we focused on signalization at an intersection here, and there are 2 more farther north. So the data that was used in our project primarily came from the emails that the Jets provided us. We used the parking lot capacities in our simulations to determine the expected flows that we would get post-game. We used the heat map that was provided to determine when and where we were going to reroute traffic and which roads that we could reutilize.
Hello, my name is Zach. I took a little bit of different approach. I used the program Reversible, which is a bit more user-friendly, and I was able to create this test model for the southwest exit. The basis of the program is creating links that act as roads and then producing cars at a static volume of vehicles per hour. This model also shows a preliminary view of the stack-up issue we see, and I'll discuss how I tried to fix that with another model.
So this is how I developed the prototype using Sumo. I downloaded the program and I went to OpenStreetMap to download an OSM file, and I used Python open source code to generate these files. And what that did for me was it created random trips with vehicles that departed from specific junctions at specific times and followed specific routes. And all the geometry on the OSM file is generated in these extremely large XML files and creates junctions and traffic lights. It creates this large file that creates all these cars that travel on different routes throughout the simulation.
Okay. I modeled the south exit in Reversible because we saw on the heat map that there was a possible congestion near the toll booth, and when I modeled it, we found that there does seem to be a decent amount of congestion. The toll booth itself is basically 4 separated lanes, so they can't change lanes, with some slow down zones to model easy pass users, and then basically equivalent to a stop sign to model people taking a ticket. And afterwards, it's basically free for all, how it is after the toll booth. We did see that similar build up, so we modeled our solution as well. And in our solution, we performed a lane diversion to kind of divert people to the north exit or south exit to 95 before the toll booth, as you can see in this split down the middle. And then we also implemented modeled an implementation of alternative to them picking up a toll ticket at the toll booth by removing those stop signs. And that could be done by either having them use their game ticket as a toll booth ticket or just having some other way for them to print it off. And we would improve the simulation what would make the simulation better would be to get a more reasonable or a better input for these traffic inputs, because these are more estimates from what we have. And also connecting previous models in for other exits, connecting them all together to get a more overall view of the entire system.
So in the test and redesign section, I'm going to show you how the Sumo simulation works and how we would implement that to get output or results to see if our solution would work. So at the start of the solution, it starts generating cars. So I stopped it to show you how it works. So you click on the car and you show the car's current route. And so what we would need to do to make this a more accurate solution would be to select this car and hope it's on the route which we want it, and it's on one of the routes we want it as it exits through that northwest exit that we saw. And to create a more accurate representation, I would have to take this car and go to its ID here, and I believe it was 43. And I have to go in here and find vehicle 43, and I'd have to copy that vehicle depending on what proportion of the lot capacity would be cars going to that northwest exit. And so this creates obviously a time-consuming method to produce because I have to not only do that for this parking lot, but all the parking lots depending on how many cars you want to go places. And then to do the traffic signalization, we would have to find the traffic signals here and further, and we would need to find those in this file and change the information in those that corresponds to the signal length, as well as creating junctions here to move normal flow of traffic on these interstates surrounding the state. So the main final solution focused on the VISM simulation. This allowed us to create a more instantaneous solution and a more complete solution for exits. Obviously there are things that need to be improved on with better field data and more time spent on the solution, but I believe that we had gotten a good start. So the solution focused on showing what information we got from the base maps and what information we got, or the heat maps and the information we got from the jets on the parking lot's capacity, and running a preliminary simulation and comparing it to post simulation, which showed our changes to the sites as seen in the south and the preliminary south and after the fixed south. So the main people who are going to benefit from this are the fans and the jets. The fans get a faster egress time, and it'll be easier to use, and they could see a quicker turnaround from the old egress times to the new ones, since it's easy to implement. And hopefully the jets can deliver a better product to the fans, and it won't cost them a lot to do this. A very low cost solution. And there are several simulations that can prove this to them. So the proposed final solution, again, like stated in the previous video, is mainly using bottleneck removal techniques on Stadium Club Road, and then miscellaneous techniques such as the ticket booth on the south exit. The challenge, obviously addressed by the solution, is to reduce the egress time significantly while giving the just a cost-effective solution. So we obviously researched some federal highway bottleneck removal techniques and looked at the heat map provided by the jets to determine where the areas of main conflict were. We used simulations to develop this, so we got a rough idea The main benefits obviously are it's cost effective, fans will find it very easy to use, it's easy to implement. The areas for main improvement would be to finish the simulations, but that would require a lot of field data to create a more accurate model.